And welcome back, students. We're going to today discuss variables. These are not just a thing for math, these are also used in computer science. So we're going to specifically deal with talking about things like expressions and also assignment statements. So just some terminology to kind of throw at you to kind of get us started for this lesson. The first one is identifier. This is the name of a variable or any object you want to identify within a program. Our next term is what is known as case sensitivity. Capitalization matters in C#. Uppercase is different from lowercase. Keywords, these are special reserved words that have a predefined meaning, such as the term public. There are other ones like private, using system, all these other terms that are already used by the programming language, so we can't create our own object with those terms. Next is declaration, which is telling the compiler and therefore the computer what kind of variable you're using. And lastly, we have primitive types. These are the basic types of characters that are used by C#. All right, and here are some primitive types. And this quick table that kind of tells you what they are used for. So, example, we have a byte, which is 8 bits or 1 byte of information. That's an undefined integer. We have an int, which is going to be one of our most common ones that we're going to use. That's a signed integer. The big ones you're going to need to know, besides byte, int, short, long, float, double, char, bool, these are the big types are here. What you're going to want to know more than anything is this side of the column right here and this right column. So the left and right column. Middle column is just more for informational value, but you really need to know, for example, is that an int is 4 bytes, short is 2, long is 8, float is 4, etc. All right. Additionally, when we talk about these three right here, int, short, and long, these are integers, all right, which means these are whole numbers. When I start talking about float, double, and char, or excuse me, just float and double are decimal type numbers. So that's a good thing to remember there. So again, int, short, and long are all integers or whole numbers, positive or negative. A float or a double is a decimal type number. Char are just that they're characters, so it's any character pretty much on your keyboard, so things like a space, any letter, number on your keyboard can be represented as a char. And lastly, you have bool. Bool are your logical types, so it's either they're going to be a true value or a false value. All right, and those are 1 byte. All right, so now that we looked at all those different types, and I'm sure you might be a little overwhelmed with all the different types, let's actually look at them. And we're going to start simple here. We're just going to mostly use int and double to kind of start us off here, because that will keep it simple without making you feel overwhelmed. In fact, most of what we're going to use, you're only going to need to use int or double. So variables, just like in math, are used to represent an unknown value. However, there are different kinds of variables depending on what they are declared as. So if we want to declare a variable, we use the following format. The type of the variable, followed by the name. So for example, I can have int number. Int is the type, number is the name. Char answer. Char is the type, answer is the name. If I were to do a double one, it'd just be, let's say, double average. Double is the type, average is the name. Now, one of the nice things about C#, and this also happens in other programming languages, but you can declare multiple variables of the same type on the same line, which helps me save on having to rewrite out stuff multiple times. So here I have int count number wave, double speed distance. You'll notice that each of these have their own line of code. So int count number wave is 1 line because it ends with a semicolon. Then a new line I can have double speed comma distance. These are 2 different lines of code, but you'll notice I could have done int count semicolon, int number semicolon, int wave semicolon, but I chose not to. All right, and I'll show this again when we get to the coding example. Assignment statements. These are how we really help utilize variables, because declaring variables doesn't do us any good if we can't actually use them. So yeah, I might create a variable called int number, but if I can't use int number, why did I waste my time? So if we want to assign values to a variable, we use the following format. Variable equals expression. So for example, x equals 3, y equals 2. So now the variable x has a value of 3, y has a value of 2. We can even assign variables to be defined by other variables, right, such as rate equals 15, time equals 20, and distance equals rate times time. Now, one thing to note, if you're going to do this, you have to first declare a variable before you can assign a value. So a variable has to be declared, it has to be defined what type. So if I just put in my code x equals 3, I'm going to get an error. But if I put in int x equals 3, we're good. Or if I put int x and then x equals 3, we're fine as well. And that ties right here into initializing. Okay. So until a variable is given a value, it is called uninitialized. So some quick examples: char initial equals b, int number equals 19, count, and then answer equals 50. Now you will notice here with this last example that count is a little different than number and answer in that it does not have a value. And that is fine. You don't actually have to, right at the start, necessarily give your variables a value. A lot of times it's good practice, to give them even a value of 0 or something, just so they can start with something. But you technically don't have to give them a value until you need them. So in this example, it just shows you that here we have number and answer are initialized. Number is initialized to 19, answer is initialized to 15, and count doesn't have any value right now. It just exists. All right. Usually, not always when a variable is declared, we give it that initial value. So as you can notice, we had number is 19, answer was 15, initial was B. Again, count had nothing. Some compatibility to note: you cannot mix two different types of variables. So for example, int variable equals 2.99. 2.99 is not a whole number. Right? This is an example of a double or float. It's a decimal type number. And it's most likely going to throw a type mismatch error. And the reason for that is because, is 2.99 a whole number? No. If you remember, int, as I mentioned, was only a whole number. So you cannot do this. Don't try to do this. You can like int variable equals 3, int variable equals 2. That would be fine. But you cannot do int variable equals 2.99. Now, before I move on, we'll just real quickly talk about parentheses and precedence. Just like the orders of operations in math, things in parentheses in programming occur first. Operations like addition and subtraction are underneath that of multiplication and division, because multiplication and division have higher precedence than addition and subtraction. After that, it's just like we know in math, we follow left to right in order. So when doubt, think back to your PEMDAS. Please use my dear and silent. All right. A quick example here for you: base plus rate times time. Rate will be multiplied by time before being added to that base. All right. So again, multiplication occurs first. All right, real quick, I want to talk about integer and floating point division. So unlike regular math, an integer divided by a decimal will not yield the decimal. So if I do 4 divided by 3, I'm not going to get 1.3 repeating like we would normally get. We would expect it to be 4/3, but it's not. Because if I have 4 divided by 3, and these are both ints, so let's say int a equals 4, and int b equals 3, and I do a divided by b, I get 1. I don't get 1.3 repeating. And this has to do with how integers work. Remember, integers are just whole numbers, so it doesn't bother to try and calculate the decimal. So if I wanted, for example, just to find out what the remainder would be of that operation, I need to use the modulus operator, or it looks like a percent sign. So if I write 14 mod 3, I get an answer of 2. Because if I take 3 into 14, it goes out 4 times, and I'm left with a remainder of 2. Right? That's really all it is. So, assuming not 3, but 4 times. So 4 remainder 2. Now, that leads me into my next point here. Right? Let's say we want to divide 4 by 5. If we enter 4 and 5 as int types, we're not going to get the answer of 0.8. We're going to get an answer of 0. Right? And this ties back to that integer example I gave earlier, either with int variable equals 2.99. Same kind of thing goes on here. So to force it to change, let's look at this example. Double x equals 12.34. Int a is equal to parentheses int parentheses x. The value of a would now be 12. What this does right here, by putting this here in parentheses before my value, is it does what's called coercion. It forces the program to change the decimal value to an integer value. So let's look at our example of 4 and 5 that I have above. So 4 divided by 5. So if I wanted to get the answer, first off, I have to store that into a double. So double ands, right? Because if I just did double ands equals 4 divided by 5, I'm not going to get the answer I want. But if I do double ands equals 4 divided by double 5, I'm much more likely to get the result I want. All right, last thing to talk about is the incrementer and decrementer. To increase the value of variable by 1, we can use the incrementer. So I can just say x plus plus, and increases it by 1. So here I have an example of x equals 2, x plus plus, x is now equal to 3. To increase the value of a variable by 1, we can use the minus minus decrementer. So x equals 2, x minus minus, x is now 1. Now, you might be wondering, okay, because this is just minus 1, can't I just do, a subtraction of 1 or an addition of 1? The reasoning has really to do with loops, which prefer the plus plus and the minus minus, as arithmetic operations don't work in loop conditions. Logical operations will, which are things like less than, greater than, equal to, but you can't do arithmetic operations. Now, at this point, don't really worry about what I'm talking about when I start talking about loops, because we haven't gotten to that point of our programming yet. But it is something for you to really keep track of in your mind of the reasoning why this is. All right, so that's the end of this presentation. So let's go over to Visual Studio, and I'm going to close my Hello World program here, and we're going to get ready to do a variable example here. So I'm going to go ahead and create a new project. Again, I'm going to choose Console App, and I'm going to call this Variable Demo. And I'm going to leave that here in my programming folder. Click OK. Again, Visual Studio is going to ask me, I'm going to click OK. And you can see in here we have our program made. Here's using system. Here's our Hello World line again. Right? But what we want to do for today's purpose is go through and create some variables. So let's just delete this console.writeline Hello World to start off. And let's make a couple variables here. So I'm going to say int x, int y, and let's make one double z. Okay. So I have 3 variables right now. Now, as I mentioned before, we can actually clean this code up to make it a lot easier to look at. So rather, if I didn't want to type int x, int y, I could actually put a comma here and just hit the delete key. And I can put this all in one line. So now I have int comma x, y, double z. So it really helps clean up my code a lot. All right. Now, one thing to note here as we start talking about variables, it's a common practice to name our variables to something that's relevant. So if it's a number, we might call it num. If it is like something like the average, we might call it average. Those sorts of things. So here I have, again, I have 2 variables, 3 variables actually. 2 are ints, 1 is double. If I want to assign these values, all I need to do is I can come right here, type equals, and let's just give x a value of 3, and we have y a value of 2. All right. Now z, I'm just going to do something real simple here. I'm just going to give it the value of 2.5. Okay. Now, if I wanted to have a variable that's uninitialized at this current time, let's say I want to add another variable in, and I'm just going to call that variable answer. All right, I'm going to make that a double, so I'm just going to call that answer. And I can just leave that there right now with no value. And the reason I can do that is because you don't have to initialize a variable right away. Okay, so let's go ahead and see these appear in a program. So I'm going to do a console.writeline. And in here, let's just output x. And I'm going to after that a console.readline just so my program stays open. Save that. And let's go ahead and run variable demo. Right. And you'll see that it outputs the value 3, which is what is stored in x. X equals 3, so it outputs the value 3. Now you'll notice if I want to put more in there, if I want to put, let's say, y, I cannot put x, I can't just go x comma y or x plus y, anything like that, because that's not going to get the operation I want. If I want to see the value of y, I have to output another console.writeLine, and I have to put y in there. Now it would output, if I run this again, 3, 2. Because 3 is the value of x, 2 is the value of y. Right? Now, at this point, let's just go ahead and do a little bit of math to this. Okay? So, I'm going to add in here a console. Actually, that's not even just that. It's just, let's have answer receive the value of x plus y. Okay? Then I'm going to do console.writeLine of, I'm not going to do x or y because I want to output the value of answer. So I type answer. Never type the actual value. Even though, yes, I know what 3 plus 2 is. I know it's 5. I don't want to type in here 5. That's not what we want to do. We want to use the variable name because if I go through and I change it, I'll show you here in a second, it's going to make it a lot easier for it to update. All right? So let's run this quick. 3, 2, 5. Great. Okay. Now, the reason why I say you don't want to put a number in there, let's just say I come back here and I say, hey, I want to change y from 2 to 5. If you had put 5 in here, your program would have been incorrect because now when I run it, we get 3, 5, 8, which is correct. So you have to make sure that you're putting in the variable, not the number value. Now, let's just say I want to, after this, update my value of one of my variables. So let's just say I want to take y and I want to add, let's just say I want to subtract 2 from it, all right, or add 2 to it. Doesn't matter. If I just put y minus 2, semicolon, you'll see that I have an error. All right, this is a very common mistake that students started off making. It's because you need to tell the program where do you want to put that y minus 2. Because if you just put y minus 2, it doesn't know. So what I'm going to do is I want to take y minus 2, and I'm actually going to take that and store it back, and I can either store that in y, for example, or I could store it in a different variable if I want. I could store it in z. I could store it in x. It doesn't matter as long as it's a type that can hold that number. So I put y equals y minus 2. So now I'm just going to do a console.writeLine of this, just so you can see what that is going to be. Since we changed the value of y, we should expect at this point, remember y was 5. If we subtract 2, we should expect it to be 3. So let's just run our program. We get 3, 5, 8, 3. Very good. All right. Now, a couple other things I just want to do real quick here with you is quickly do an example of parentheses. So let's do a console.writeLine. And in here, I'm going to do, let's say, parentheses x plus z, parentheses. And let's just do that times y. Now, the important thing to note about this is that it does not change the value of x, y, and z. In here, x, y, and z are still the same. And I can put console.writeLine statements after this to show that. Instead, it's just going to do the math. So if I run this, x plus z times y, I get 16.5, which is correct. Because, again, I simply just did the math. I didn't change the variables. I only did the math. All right. Now, one of the last things I want to do is just show you how to use some like the incrementers and decrementers, and then I'm going to pretty much kind of call it a wrap. So let's just say I want to increment the value of x. So to increment the value of x, I can just put x plus plus and with a semicolon. You notice that I do not need to put x equals x plus 1. Because even though it's the same thing, x plus plus does the exact same thing, because remember, it adds 1. So if I put x plus plus, well, now that's the same thing as saying x is equal to x plus 2. So really, I could come back here and change this one really if I wanted to be like a y minus 2. I could find a way to shorten it. But I'm just going to use x plus plus here. And you'll see that if I output that, console.writeLine of x, you will see the x is now 4. Remember, x was originally 3, but now it's 4. All right. Now, let's just do a quick decrementer example. I'm going to decrement z this time, and it doesn't matter that it's a double. It works the exact same way. And you can see right here's my decrement example. It was 2.5, now it's 1.5. Right. A couple other ones just to give you examples of how they work. Well, let's just do a quick modulus operation. So let's just do console dot writeline of, let's do, since actually I want to go through and change this here, I'm going to make changes back to 6 just so we got 8, because when we subtract 2 I want that to be 4. So I'm just going to do x divided by y. Okay, so in here I have x divided by y, which if I run this program right now, I get 1. Right? And remember, x at this current time is 3, y at this current time is 4. Oh, excuse me, x is 4. So because we're incremented, I forgot about that. So actually I could put this back at 5, I think. We'll be fine. Forgot I incremented that value of x. Alright, still getting 1. Now the reason for that is because, remember, this is an integer operation. Right? So let's just do a console.writeline of x mod y and see what the current remainder is. Because if we get a remainder, that means we have a fraction. So let's go ahead and run that. All right, and it got 1. So that's a remainder of 1, which tells me, yes, this is a fraction. So to go ahead and make this output as a decimal, the easiest way to do this is I can use answer, because it's just sitting there, is equal to, and I can do x divided by y. Now, if I just try to do a console.writeline of answer at this current time, it's still going to come back as 1 because, remember, we have to typecast. Boom, 1. We don't want that to be 1, so we have to typecast this. So I'm going to add in here double. Okay. And now if I rerun this, you'll see I get 1.3 repeating, which is what I wanted. Okay. And that's pretty much about everything you're going to end up seeing in the lab. There's like 3 labs that you guys are going to be doing. So again, it's a pretty straightforward approach to doing variables. I highly recommend that you guys have these exercises here, again, as always, to help you with this. Because here's a quick example of how to do a lot of this stuff. Now, you probably say, I'm going to forget it, or I'm going to have questions. That's great. You know. But again, it's really at the fundamental level still. You haven't done anything too crazy. So I think this is a good spot right here to kind of stop. And I will see you folks next time.